Recording in progress.
All right, here we go. Chapter 26. So we're getting over the end of this thing. All right, here we go. All right. Oh, and I forgot to hand I did run these off. Did make some questions here. All right, here we go. Like to see the paper, you know. Here's 26 now. I'm stressed for time. I was going to try to do 27 yesterday. I didn't get to it. I just trying to stay ahead of the lunch file, which is in order to do this year. All right, here we go. So we're making it. We got 2 weeks of, we got lab finals next week, and then lecture finals the next week. Right? So everybody's on task. Okay. All right. Should be, and so we all should be. To know where we're at. All right, so this is actually a very interesting chapter, and they cover this first topic is actually questions 1 and 2 on your review sheet we're going to address. But as you'll see, as we go into this, is a very interesting chapter, and it is a chapter that is needed on the species end, right? So it's kind of important that reproduction occurs, right? And it is the way that we continue the species, right? And to really understand it, the first thing it's going to do is going to talk about the concept that I alluded to in lab when we did mitosis back in chapter 3. Remember, chapter 3 was like an epic chapter, like 3 chapters all together. You know, it was like cell division. What all was in that, man? I forgot. Metabolism, I think a little bit anyway. It's a pretty epic chapter. All the parts of the cell and how cells divide, and that was protein synthesis. Remember, it was in there too, right? Remember, evil transcription and translation. Okay, but in the middle of that, in the chapter on cell division, we talked about a concept called mitosis, right? And that was nuclear division when we maintained the chromosome number. If you remember, right? So that mitosis was growth and repair, right? We have 46 chromosomes in every cell of our body. Get a pen up here. So we have 46 chromosomes in every cell of our body, and when they divide, each cell is going to get what? 46 chromosomes, right? And that way we maintain the chromosome number, right? Remember? Prophase, metaphase, anaphase, and telophase. A little review, right? Now, that's not going to be good though, because when we want to do a chapter of reproduction, we're going to have an egg from the female get fertilized by a sperm from the male. And if it has 46 in it, then you got a problem, right? You got 92 chromosomes, and that's going to be a dead baby, dead embryo, right? So if you get more than 1 chromosomes of any of them, you start to have problems, right? And then just a few of them can even live, right? For example, Down syndrome with 321, right? Is about the one that's most common to have a normal life. Well, they don't actually have a normal lifespan, but they have a relatively normal lifespan. Their average lifespan is found in the 50s versus 75 for a human born today in America, right? So they actually do die a little bit younger, but they can have a relatively, decent lifespan there. So what we got to do is we're going to have another type of nuclear division where we cut the chromosome number to 23. Okay. Now, if you remember, we did this through a prophase, metaphase, anaphase, and telophase, right? But what we're going to see here, just as a quick review, we're going to see that in meiosis, we're going to have 2 divisions. We're going to have meiosis 1, where the 23 pairs line up. So each cell is going to get 1 of each of the 23 pairs. See, so actually the 23 pairs line up, and each cell is going to get 1 of each type. So you're going to end up with a division where you're going to do a prophase, metaphase, anaphase, and telophase, and each cell is going to go from 2 of each chromosome pair to 1. And when you have 2 of each type, that is said to be diploid. When you have 1, that is said to be haploid. So there are 23 pairs. So at conception, remember, you got 23 chromosomes from daddy of each type, 1 through 23, with 23 being the sex chromosomes, X or Y. And then mother also donated 23 chromosomes in her eggs, which are the copy she got from her parents, right? So it's kind of a cool passing down from parents to their children to their children, right? All the way through this germline, right? And so in this second to first division, we're going to separate the pairs. So each cell gets 1 of each type. And then we do another division. And of course, I have enough room here to see this. See if I can put it over here now. So we're going to see another division called meiosis 2, which is a lot like prophase, so that each of these, we end up with 4 cells, each with 23 unduplicated chromosomes. Because if you remember, this is a big deal. The X, and I made a big deal about this, an X is actually a duplicated chromosome. This is a photocopy of this. And that's how we're able to achieve that in mitosis, right? Because we just separate sister chromatids and interphase, then they replicate again. Remember during the S cycle of the cell cycle, remember they replicate their DNA. So in normal cell division, you just separate sister chromatids. So when you see an X, that's a duplicated chromosome, and then anaphase, they pull apart like this. Now we say we have two. You go from one duplicated chromosome to two unduplicated chromosomes. Okay, that's how we do that trick. So meiosis 2 is really what? Pretty much mitosis, right? Where you separate sister chromatids, right? And each side becomes the chromosome itself. Okay. Now we're gonna look at that quite a bit here. We're gonna see several. Get this picture off here of that. So we're gonna look at meiosis now. So this is gonna occur in our gonads, right? And the gonads is the name for our sperm or egg producing structure, the testes in the male in humans, and the ovary in the female, right? And the gamete is the sex cells, which would be sperm and egg for us, okay? And then, of course, in the same chapter, we're going to look at all the accessory organs that allow us to get those two together. So the sperm and egg can get the fallopian tube together and fertilize, and then the embryo can implant in the uterus. And that is where our babies are going to grow for 9 months right till they're born, okay? All right, so at fertilization, we're going to I think she's going to go back over this just real quick. But there's mitosis, where we call somatic cells of divide, that's growth and repair. And meiosis is, we're going to see nuclear division, where we cut the chromosome over in half. Fertilization is when a sperm and egg hit each other, come together, and this occurs in the fallopian tube, and then you become a one-cell entity called the zygote, okay? And it must contain the correct number of chromosomes, half from the egg from mother and half from the sperm from dad, or there's some real problems, right? Side note, there's only one human that can live with 45 chromosomes. So there are some women that are called Turner syndrome that have an X from one parent and no chromosome on the sex chromosome of the other. So we call those, it's called XO or Turner syndrome. So they're the only viable humans with 45 chromosomes. If an embryo gets a Y for that 45th and not an X, then none of those have ever been born and lived. There's never been a medical record of anybody been born with that yet. So there's not enough DNA on the Y by itself to sustain life, it appears, okay? Which is kind of interesting, okay? All right, let's take a look a little bit farther. So here we go. So meiosis is going to be this nuclear division where we cut the chromosome number in half so that we can have sperm and egg have 23 chromosomes or go from 2N to this haploid. So here we have a nada. The nada is our organism that doesn't exist, right? A pretend organism that has how many pairs of chromosomes? 2 pairs, right? Now we have 23 pairs, right? So let's just look at it under a 2-paired organism, okay? And we'll just make the blue ones dad chromosomes and the purple mother's chromosomes, right? So you have 2 big ones there and 2 little ones, and that could be 1 and 2. We would have 23 of those based on size, okay? Now, they're going to replicate during interphase, right? Remember, chromatin is when it's unraveled. When the chromosome is unraveled, it's no chromatin. And here they are coming back into prophase, coiled up, and we have these coiled up. And here they've actually paired up as they will do in meiosis 1, okay? And we'll see some drawings of this. Let's get to meiosis. We'll see some pictures. So here it is. It's kind of what I tried to draw. So in prophase 1, the 23 pairs come together. Now, in regular mitosis, what happens? The 46 chromosomes line up in a straight line, and they pull apart in anaphase, right? But here we see something weird. The 23 pairs come together, okay? And then they line up, and then in anaphase 1, we're going to pull so that each pair, each side gets one of the one of each pair. So you end up with 2 cells now, each that went from 4 chromosomes, right? Diploid, 2 of each type here, to haploid, 1 of each type. Okay. Now, as we're looking at this, I always like to tell a funny story with this. So number 2 asks, why is it possible for 2 people to have the same genetic code on Earth except for identical twins? So I have to dedicate this lecture this morning to my mother. Okay, I love my mother. She's still alive, and I don't figure I'll have them much longer because I can drop dead today, right? But they're about 78 with my parents. And but how many of y'all had a parent that maybe did y'all dad whip y'all? How many of y'all got whipped? Okay, good. Okay, how many of y'all did get whipped? Okay, y'all need to be. I got a therapist for y'all. Y'all probably need to be in therapy, right? Okay. And somebody told me a really smart one here today. Listen to this, and I heard this over the weekend. Spoil your children. Wait. Raise your children, spoil your grandchildren, or spoil your children and raise your grandchildren. That's an interesting statement, right? I said again, it's kind of interesting, right? spoil your children, raise your grandchildren. Raise your children, spoil your grandkids. It usually works one of those two ways. Now, I'm not saying, look, I know people that abuse stuff. I have to see, that's a friend of mine that they never whip their kids and they set them in the corner and they're really productive citizens today. So everybody's different. So I don't even think whipping helps for some people, right? So some people just don't respond to that. But I do think though that we probably have had some issues in there in that area. But I tell this story. My mother didn't like to whip me. She liked to do the psychological warfare. Daddy whipped me. But it would be the old dad would be home at 6 or 7 o'clock tonight, and he'd make you go pick a stick and whip you, go pick your own, punishment, go out there and pull a branch, that he's gonna whip you with or whatever, right? But his dad was like, not gonna come home or anything, if he's on a trip or something, here's what you do. This is our psychological warfare. If you do not eat your food and clean your room, we're gonna take you to Memphis, where we went to visit Uncle Bobdell. And when we go to Uncle Bobdell's, we'd go up to the airport and watch the planes land and take off, which was a big deal back in the 70s. They lived in a park on the south side of the airport that you can go and get crystal meth today and watch the planes landing up. It's pretty rough little park, turned into a rough neighborhood. But FedEx taking off and landing is pretty impressive. Have y'all seen that, right? When they whooping in at night, I mean, that's pretty impressive. It's still worth seeing. And we're going to put you on a plane and take you to Russia, where there's a little fat Robin. Your identical twin is in Russia. And he gets one potato a week, which I don't know why I didn't realize he would be fat if he had one potato a week to eat. But just a kid, they lie to 6-year-old. And he had one toy, a cart with 3 wheels. And I had all the toys in the world. And we're going to swap y'all and bring that other Robin back, who will be respectful and clean his room and eat all his vegetables right, because he has not had such things that you have had. And I believe that. Guess what? My mother is a liar. There is no Robin in Russia. There is no Robin anywhere else on earth. There is no you anywhere else on earth unless you have done the twin. And I'm going to prove my mother a liar today using the power of mathematics and science, okay? So there are 3 places where we see some really cool stuff going on here that makes it statistically impossible for 2 identical people to be on earth. Okay, that's clear. Okay, and the first one is right here. This random alignment where these pairs spread apart right here is absolutely astronomical statistical stuff here. Check this out. Think about this. Even with a nada here, look, let's just draw all the possible ways they can split up right here. Okay, you can get what? You can get both daddy. Let's put dad for the D by dad. Okay, or you can get what? Both mama, right? You can get big daddy. Okay, big daddy and little mama, right? Or you could get let me get my story straight. Big daddy, right? Or we could flip it and get all mama. Okay. Or anyway, you can say you can get these 2 together or these 2 together. There's 4 ways you can split those up. And the way you do that is it's 2, and there's 2 of them. So 2 to the second pair is 4. But how many pairs do we have? We're not an island with 2 pairs. How many pairs do we have? How many pairs? Okay, how many chromosomes do we have? 46. How many pairs do we have? 23. Thank you. This is a rocket science. That number is 7,868,462. So right off the bat, there are 8 million combinations that you can put together of just your 23 pairs into your sperm and egg. That's crazy. There's 8 billion different sperm or eggs you can make just simply based on how you what? How you shuffle your 23 pairs, right? Now go with me here. Let's just think about that for a minute. So I look a lot like my mother's daddy. They say I'm exactly like him. So I may have 22 or 23 of my what? My mother's dad, my granddad, that's what they came to me. And so I would be one out of what? 8 million combinations, right? That is 22 daddy chromosomes and 1 mother of her that made me. And this is how you can have a son that looks so much like a grandparent, right? And then other children, like I look nothing like the Robisons. You would think that my mother had an affair with somebody, right? I mean, I don't look like my dad's family at all because I think the herring genes were dominant. Brown hair, brown eyes, stuff like that over some of the other genes, right? Then we have to have dominant recessive. So the first big answer for number 2 there is what's called random alignment at metaphase 1. So how these line up right here is totally random. There's no little munchkin saying, everybody from dad, get over here, and everybody from mother, get over here. It's random alignment, like shuffling a deck. And there's about 8 million ways they can line up. That's crazy. Okay. Now, did anybody notice something here on this blow up here? How that one has got some of the purple on it. Did anybody catch that? Anybody see how they're not all blue and all purple? Okay, well, let me show you what's going on there. At prophase 1, what's this? Wait, I went through it. I already went through it because I want to get the picture. But at prophase 1, look at this. This is crazy. The chromosomes pair up like this, and they swap apple for apples and oranges for oranges. They do a process called crossing over, where they swap some of their DNA. Okay, let me do that. And look. I love how people they hear about 10% of what I say, and then they get mad about it, and then hear the whole thing. I'm going to do me, okay? This is me. So I'm not making fun of anybody, I'm making fun of me, okay? What? So let's say that when my mother made me, or let's look at it like this. Here we go. So I am short and ugly, and I want to have children, and I have no choice. I mean, my children are pretty much toast, right? So my dad, so watch this. My dad is, let's see here. He's tall. He's cute. He is thin, but he's not smart. He is average intelligence. He ain't the smartest person in the world. Okay. My mother is short. She's ugly. She is fat, and she is smart. So my children are either going to be short, ugly, fat, or smart. That's my contribution for me, for that chromosome, right? Or they're going to be tall, cute, thin, with sort of a dull mouth. Not the smartest person in the world. And that's it. My children have to get that one of those two chromosomes from me, or they're not even going to be normal, right? Isn't that kind of sad? So all our children can be is what we have, right? Your contribution and your husband or wife's contribution. Right? It's kind of scary. So be careful who you have children with. It's kind of a scary thought, right? But what if I told you something crazy goes on here? So at prophase 1, these come together and swap pieces for pieces. So let's say it breaks right here. And now over here, we got what? Tall, cute, and thin, and smart. Obviously the one that made me, right? Are short, fat, thin, ugly, and sit down. Your number 1, number 2, number 3, all of your pairs are coming together and swapping apples for apples, oranges for oranges. This is called crossing over, and we think it occurs in at least 4 or 5 chromosomes every time you make a batch of egg or sperm. So think about this. Let's just say, anybody know like about poker? Poker, like poker, like royal flush is the best hand you can have, right? But in 2-card poker, like the queen, king, ace is really amazing, right? The same speed, or 2 aces is just really strong, right? So let's just say in a game of poker, I got a jack and a 3 of different suits. You're gonna lose, okay? A jack and a 3 is jack high. That's it. What if I told you you cut them together and maybe come up with a 2-3 straight? You're mixing your chromosomes together right now, and that's one of the reasons why everybody's different, right? Because it's always going to be different. You won't be the same batch every time. It's called crossing over. Is that a pretty cool example? And of course, all those genes are not on me. That's a representation of what could be happening, right? So you may be ugly, and your wife is ugly, or your husband's ugly, and you come out with freaking Miss America. Anybody peer review right? There's a beautiful woman on stage. You see some of the parents are ugly than me. Some of them, right? So one of the best ways you can tell what you're marrying, guys or girls, is look at their parents. Anybody here date a girl or guy whose parents were smoking hot? Anybody? Come on, man. I had a girl one time jump up. She said, one of my favorite students one year, she's like, man, I've been dating this guy for 2 years, and he is good looking, but his daddy is freaking 10.10. I mean, smoking hot. And later on, like April, they broke up, and I started asking her, I said, you ain't hitting on the daddy, are you? She didn't. She dated somebody else. Well, but you know what I'm saying? If your boyfriend's parents are good looking and your daddy looks young at 52, grab a hold of him, he's gonna look good at 50, right? Okay. But if you go home and her parents go, whoo, give you the scare, you might want to, if looks at everything, you might want to date somebody else. Because that's probably what you're gonna have in 34 years. Possibility, right? Not always the case, but it is an indicator, right? An indicator. Okay. So everybody got the crossover is really cool, right? So this is how we're able to take cells and cut our DNA up and sew them back together to make new combinations. So I always say this, everybody has the greatness in their DNA, and everybody's got Jeffrey Dahmer in their DNA possibly, right? And for those who don't remember, I got to update my story, but that was a dude back in the 80s that liked to collect little boys and bury them under his house and eat them over the next 6 months. And he ended up got arrested, put in jail, and he got killed in the bathroom. Because even criminals in prison can't put up with people who little boys, right? They said, I ain't living next to him. And they cleaned their neighborhood. Okay, they got in the shower and killed him with a broom, I believe it was. But anyway, pretty wild. Okay, so let's review. Random alignment, metaphase 1 is a big one, 8 billion combinations, right? And then this crossing over, prophase 1 actually swapped pieces of DNA that we saw right here. I think they did a picture of it, and maybe I got in a hurry. Oh, come on, man. Show me that. They usually blow that up and show that change in here somewhere. Okay, never mind. See if they do here. We'll go a little bit farther. Come on. Well, you can see it there. See how it's broke apart, how that poured off the big one with the other one? Okay, and then the second one, here's a summary of it all. The third one is this. Think about this. And I'm not trying to be dirty, Lord knows I don't need anybody calling, in therapy over this. But a married couple is going to practice a lot, okay? You're not going to have a kid. Hopefully, if you have 2 children, you will have sex with your husband more than twice, right? In 30 years, right? So think about all the times a couple gets together. We don't even try to calculate that. And practice. And every time the male has sex, it's 500 million sperm. Everybody in this room has done won the lottery. You in the game. You were seriously. Everybody in here, just being here, you don't want the Powerball lottery. What are the odds of one sperm in mom and dad's reproductive history? And one of her 400 eggs, she ovulates in her reproductive time from 15 to 45, 50, would be the one to make her 2 children. Like I have 2 children, I'm using this example. Not counting the fact anybody had an affair or anything, right? Remember that? Not counting mama had an affair with somebody or something, whatever, or just assuming nobody but them. Okay? You won the lottery. It's chichirian, the odds of you being conceived. And another phone here, just on the front of this, look at this. Let's go back to that number. I said 23 square. Look at this. 23 to the square, I said was 8 million. But look at this. Can you make your own baby? No. So you got to have what? 23 to the what? Square, right? So that comes out to 73. So 73. So a couple, Adam and Eve, could make 70 trillion different humans out just their chromosomes. Just what they had at Adam and Eve had in the Garden of Eden. And we haven't had 70 trillion on Earth yet. We've only had maybe 10 trillion people ever be alive on Earth. So it is a mathematical impossibility that your combination will ever pop up again that made you, or it's ever existed in the whole timeline of Earth. Just on those facts. That's pretty wild, isn't it? So you got to square that thing again. Okay, crazy math. So a couple can make 73, and then we didn't even talk about what mutations, making new genes, right? We know that happens, right? And then that crossing over, it can make new combinations. I mean, think about this. Really, think about this. Who saw water boiling at 110, at 100 degrees centigrade, 212, right? Gets hotter and hotter, and then it just all blows up, right? Nobody saw that coming. So we don't know what kind of gene combinations occur and crossing over, and we can have some brilliance or something new on some new trait that we've never thought of before. So, in review, random alignment, metaphase 1, right? That's 8 million combinations just in you yourself, and 70 trillion in you and your husband or spouse. And then crossing over, if that happens 4 or 5 times a time, you have to multiply that times what, 4 times 70 trillion, right? If that gets up in the chichillions, that's a new number I made up. Okay, and then the third one is just the odds of any one sperm and egg ever coming together in a couple of reproductive history is astronomical. So when somebody, y'all don't even come talk to me anymore, but you try to have a student come by about midterm like, oh, I want to do something in my life. And my first thing is, hey, look, you're already in the game. You won the lottery. You're think about all the children that your parents could have had that never made it, right? And then you get sperm and egg together. So you're special. You made it to the race. Now let's figure out what your gift is and put you in the right pathway to get you into something you can make a living in. So I define success as getting a job, and paying taxes, and not going to jail. Okay, you know what I'm saying? Don't go to jail and just be a productive citizen, right? And I think y'all are all going to achieve that. I have faith in y'all. But fascinating stuff. I just love that. So this is genetics, right? But meiosis has got to be understood. So this is how we create, and this also, look around this room. Look at all the diversity in here, right? This is why we all look different. And the only two people that are the same are identical twins. One sperm, one egg come together, and that first division, they pull apart. The zygote pulls apart instead of becoming a two-cell individual. It pulls apart, and each bound in the mother's placenta into her uterus and form placenta. And so these are truly identical twins. Now, we'll talk about next week is, and it's some fun to think about that I like talking about, but what do y'all think is more important, genetics or nurture? In other words, do you think the DNA we get is more determinative of how old we can be or how we're brought up in our life experience, right? And I just think about it, right? I gotta get listed. I don't mean, I'm gonna get somebody mad, I don't want to talk politics, but whatever dude died, got married, right? I don't care about the royal family, right? Now my father's alive, all excited, Princess Diana, like all those movies. You know what I think about all the people get a freaking job, right? They inherited what? Like $1 billion, right? They inherited countries, right? That they used to own. I mean, but they still got all the jewels and stuff. They got plenty of money, right? So I just don't get so excited. I know, I mean, somebody's feelings, I mean, but I just like, and I don't know, but I just think, I'm more worried about us out here trying to, feed a kid, but then I just not a big royal fan. Didn't we fight a war over that? So we're not under them? Like the Civil War, right? We're not part of them anymore, right? But anyway, I just thought it's kind of funny to think about that. This is, to me, so cool that so we're going to talk about that next week. Is your environment more important than genetics? Because if you're born to them, I mean, Francis dies for the kids, and number one, they never have to work, right? One of them probably ended up being King England, right? The other one's going to be a movie star or whatever if they move to America, right? But what if one of them had been born to somebody in Tunica that lived in a $5,000 house and didn't have no way? Would they even come to college? Would they even be in community college? I'm just saying. Environment plays a big role. Okay, environment. Being born into the royal family would probably be a nice thing financially, but I'm sure it's a lot of stress. Sure, it's very tough being on TV all the time. You can't go to the back, you can't even go to the ball game without people asking questions. But anyway, whatever. I've never been famous enough to shall be. Okay, all right, let's go. Let's move on. But anyway, something we'll talk about that next week. So something to think about when you're reading that chapter. All right, here we go. Now, once again, please be an adult. I'm going to use the word out of the book, okay? But we're going to go through the male system and get into females. The big question I want you to know that's going to be on everybody's test is probably 4, 5, 5, and 6. I want you to be able to describe a female pregnancy cycle, non-pregnancy cycle, female cycle, and then what happens if you get pregnant. I'm going to be very clear. I'm going to answer those questions for you, okay? The pictures explain that, but we're going to maybe get to that. But let's get to the male. Okay? All right. So first thing I find very fascinating when we look at the male here, and I think that I address it in the question 3. Why is the male reproductive organ that makes the sperm, the gamete, the testes, found outside the downward cavity floating in the sac? That seems quite stupid to me. And I'm not questioning God at all here. I'm just having a fun with y'all. But we've got to have this organ for the species to continue. Everybody correct? Correct? Should we like hide it somewhere in the abdominal cavity and protect it like the ovary? That's very well protected in there, in a ball of fat, for protection. Okay, and the answer is actually quite interesting, and that is that you must have spermatogenesis won't occur at body temperature 98.6. It kills the sperm. So for some reason, the way God set it up, spermatogenesis has to be about 30 degrees below body temperature. So the testicle being in this scrotum keeps it below temperature so that spermatogenesis can occur. There are cases of infertility where a couple cannot get pregnant and simply the husband has to quick get in the hot tub overnight. I've even read cases where they had to just change their underwear from what I call female undergarment to, come on, man. A lot of guys now wear close-fitting underwear, versus the old, traditional underwear that's very loose, right? And that keeps the testicle against the body, and if they're exercising stuff, then that heat produced could kill the sperm. Okay. Now here's a side view cut through, and we just look at the organs here. You can see the testicle. We're going to see it's made out of seminal tubule. It's where the sperm is made. There's a structure behind the back part of the scrotum. It's attached to the testes called the epididymis. This is where the sperm is stored. Okay, so we do produce 30 to 40 million sperm a day, and they're stored in the epididymis. And when a male gets excited, it's just called emissions, and that is when the sperm is then carried up this vas deferens, also called ductus deferens. It's going to be carried back up into the abdomen to this ejaculatory duct area, where it is going to mix with fluid from 3 other glands. The accessory glands that contribute to what comes out of the male called semen is obviously the sperm from the testes, stored epididymis, and then there's seminal vesicle fluid, prostate fluid, and bulbourethra gland fluid. So all these mixed together with sperm only making up about 5 to 10% of what comes out of the male. Which brings me to a very interesting point. The most effective male birth control is the vasectomy, right? And that is where you go in on behind the scrotum here, cut this open. Not something men would look forward to, right? And they go in now and use like a solderizing iron, and they just melt the vas deferens together. Sometimes they used to cut it off and tie it in a knot, but now they just go in there with like a iron and just melt it together in 4 or 5 places, like melt it together, and that keeps the sperm from going back up in there. It is reversible. It's very expensive and not 100% to have that taken out and reconnected like it. So they wouldn't let an 18-year-old probably get a vasectomy today, right? Because most doctors wouldn't do that on a young person because you may not want children, but you may want them someday, right? So it's not super easily reversible. Question. Yeah. Do what, Lauren? I thought so.
But it is reversible.
But not always. It's not always. Okay. So you shouldn't have that done unless you really, really are older and know you don't want to have kids. Okay. The prostate gland, when it swells up, most of the one most common form of the cancer in men, it swells up and it makes urinating hard. And of course, you can see it swelling up, but it would squeeze the urethra and thereby prevent the male from being able to urinate very, very well. And we'll look at these fluids in a minute. The seminal vesicle is fluid, is food for the sperm. They got to have a food to make ATP to swim up the uterus, up the fallopian tube. The prostate gland also makes some alkaline fluid to neutralize the female pH, the acidity of the female vagina, so the sperm can swim up through there. And the bulbourethra gland is actually some lubricant that comes out of the male to lubricate the penis. Okay. Other part down here that's kind of interesting, you can see the foreskin, which is, we'll talk about that. So a lot of men get circumcision when we cut the foreskin off the penis for religious reasons usually. Okay. The testicle is broken down in these tubules called seminiferous tubules. Take a look. And there you got about 300 feet of tube in each testicle. If you cut into, this is what it looks like. And meiosis occurs here. The primary spermatogonium divide, and then finally at the very inside, you can see the sperm slough off. These cells are called substanticular cells, and they're also called Sertoli cells. And these are the cells that nurture and feed the sperm as they develop and divide by meiosis. And all tubes lead to the epididymis, where the sperm is stored. If you have had a vasectomy, the sperm then are just reabsorbed in the epididymis. There's no situation where the sperm builds up and causes pain or anything like that. They're just reabsorbed, unused sperm are reabsorbed in the epididymis. Cells outside the tube called interstitial cells are the cells that make testosterone. So remember, FSH triggers the Sertoli cells, the substanticular cells to produce sperm, feed, make sperm mature. LH binds the interstitial cells and triggers the male to make testosterone, the male sex hormone. So obviously, and cattle husbandry, the raising of cattle, we cut the testicles off the little bulls, right? So they don't get so mean and crazy, right? So that is something that's done to prevent the sex hormones from being made. Okay. We already mentioned epididymis, our gonad. Okay, moving on, seminal vesicle, prostate urethra. Just talk about these other chemicals mixed here. There's another slide view, cut through view. Here you can see the prefuse being removed, the circumcision, right? Okay, I think you see there, same thing here. Moving on. When the male gets excited, it is the corpus cavernosus, the spinosus fill up blood. And actually, the way that occurs is a vein is squeezed to prevent blood from leaving the penis, and then you get the erection. Okay, and here's where these chambers fill up. Corpus cavernosus and corpus spongiosus fill up with blood, and you get the erection. Okay, seminal vesicles, just talking more about that. Here's some things in the seminal fluid that makes up 60-70% of semen, food, fructose, prostaglandins that can trigger the female tract to have contractions in the uterine to help the sperm move up, and some coagulation proteins and enzymes so that it will not it coagulates so it won't come out of the girl, so the sperm will be in there and stay in the vagina. That's why, like, if a couple's trying to have a baby, they'll have the woman might hold her legs over her head for 30, 40 minutes after they get through to help gravity push the sperm down. You don't want them coming out, right? And then the seminal fluid neutralizes the acidity in the male and female urethra and the female reproductive system. It's not hospitable to the sperm. Prostate, fluid too, same thing. There's some food and some antimicrobial chemicals, right, and all that. But basically, pH neutralizer also is the main thing the fluid does there. That one we said was lubricant. Okay, normal ejaculation is 2.5 to 5 milliliters of semen. Of that, they'd be between 40 to 750 million sperm. So I just say a easy round off number of 500 million sperm. Probably the most bizarre number in all biology, right? But there would be 500 million sperm per event. And so I think this is one reason why there is a process of male reproductive birth control pill, but I think it would be very hard to stop 500 million sperm every event, right? And whereas women don't usually ovulate one egg a month, that made an easier target for the female birth control pill, as we know. It talks about how it coagulates, right, and prevents that coming out of the vagina, and then the sperm then break out, start swimming up toward the fallopian tube. Nothing much there, but we'll go through that. Prostate cancer, one of the most common forms of male cancer. It does a big debate. I would just go ahead and throw it out here to you. Big debate on how to treat this. Okay, I mean, huge debate. If you go to most doctors, surgeons, they don't want to cut it out. But how many of y'all have ever been in a garden and try to pull the weeds, right? And then you leave some roots in there, and what grows back? The weeds. Another thing, my dad had this about 10, 15 years ago. They did liquid nitrogen. They put some probes in there and froze it, and that kills all the tentacles of the cancer. And he's never had any problems out there for 20 years. So maybe cutting it out, it's hard to get all that out. You can't get all the tentacles of the cancer out. If you freeze it, you can actually go back and freeze it again. Okay, if cancer comes back. So they're always looking at this PSA blood test to see if you have the antigens for the cancer, and then of course digital rectal exam to see if the prostate is swollen. Okay, and it talks about different treatments there. There's a lot on that. Just more male stuff here. We're just going to go through that. Kind of a cool one here. There is a countercurrent mechanism here called this pamphonal plexus flow, where the warm blood is quickly taken out of this area. And I actually had a friend of mine who could not get pregnant. They could not get pregnant because they had this system wasn't working. So you had to have this cooling system, this plexiform, venous plexiform redone. And the doctor told him, y'all not going to have kids. And they told him it's not to go through his penis to get to it. And he's like, we're never going to have kids. And then they said, oh, we can do a surgery through your belly button. So he had the surgery through his belly button, and they went down to his testicle through his abdomen. And they repaired it, told him to wait a month to have sex, wait a month, wife got pregnant the first week they tried. So he was overheating his testicles and killing the sperm. Pretty wild. So infertility, 1 in 5 couples never have the number of children they want to have. Y'all didn't know that. Pretty sad number, right? So 1 out of 5 couples never have the number of children they want to have. It's pretty wild. Here it all listed for you. Kumbaya. Who's controlling all this? Obviously, that's how they start off. That's a cool little picture showing the seminal tubule, the sperm falling off there. You can see what they do, mitotic division, a meiosis division. You can see it there. Those little cells. That's little cells we used to grow in lab. FSH binds to them. It triggers spermatogenesis. And sperm has the head with the 23 chromosomes, the bid body with a lot of mitochondria to make ATP to power the tail, and then the acrosome is the enzyme that digests the egg to get the sperm in. A good question we'll see in the next chapter. When that sperm penetrates the egg, fertilization occurs, the female egg produces chemicals to kill all those sperm in the area. So we don't need nobody getting 23 more chromosomes, right? They need to be what, 96 chromosomes, that'd be messed up, right? 99. Okay, or 69, excuse me, you have 69 chromosomes. The 2 sperm goes in, and when that happens, you just have a miscarriage. So miscarriage is the way the body gets rid of any errors in development. Control here, FSH and LH from the anterior pituitary, and then testosterone and other sex hormones then go back and do negative feedback. So the male reproductive system is controlled by FSH and LH, and their effect, FSH triggers the substanticular Sertoli cells to begin spermatogenesis. And then LH binds these interstitial cells to make testosterone, and then there's chemicals from the testicle. All these can go back, and we get negative feedback to the brain. The brain controls that. We already talked about that in the male. Nitrous oxide is a neurotransmitter that's released, and Viagra triggers the production of nitrous oxide. So we now have had now for like 25 years a pill for men who cannot function, who cannot get an erection, therefore to have sex. Okay. There are a couple of pills in the process of women being developed, and another one that's kind of wild is this one actually increases blood flow in the female. So when it came out, the drug reps were telling doctors this is going to be a pill to help women too. Well, it just turned out not to. And what I was told now was that they did a test on it, a blind test where they give women Viagra, 1,000 a fake Viagra pill, and everybody had better sex, so they couldn't market it. So female reproduction is more in the mind, than it is physical. Okay, and if they told you the pill was going to work, they literally had better sex with the fake pill and the pill itself. But it does increase blood flow. It causes, it's what makes the genitals swell in the female where blood can't leave the genitals as it does. And that's how it achieves the erection in the male. And it is a gas. That's kind of wild. And orgasm, blah, blah, blah. Male usually orgasms when he releases semen. I think it's worth noting that women can get pregnant without orgasm, right? They still ovulate, so that's not required for them to be able to get pregnant, but usually the male does when sperm is released. The sperm comes out sometime when the male does ejaculate, a la many women get pregnant, right? From that, but by using that birth control method. It's not a very good idea. Infertility, 40% is the male, 60% of the time it's the female. Is there something wrong with the female plumbing? Puberty, 12 to 14. We know sexual characteristics here. Larynx enlarged, voice change, bigger muscles in general than female. Moving on. Let's get on to the go. We got just a minute. We just look at the picture. The female cycle picture that I want you to be concentrating on, and we'll go over this on the video. Y'all get it Wednesday. Let me show you this. It's a cool picture here. I can get to it. It kind of wraps up the whole thing. Sorry. Gets a little carried away. Likes that girl. The girl is a little bit more interested in the boy with all your 28-day cycle. Here we go. And there it is. There it is all summarized. So look at this real quick. So at the top, those are the anti-pituitary hormones, FSH and LH. And that's what they do in a 28-day period. Here's the ovaries swelling up, rupturing on day 14. And then there's only 2 or 3 days for a woman can get pregnant in her cycle. The cells up behind form the estrogen progesterone. Progesterone goes up, and then if you don't get pregnant, this falls off, and the falling of progesterone what triggers your period. And there's what happens to the uterus. You regrow the endometrial lining for day 1, 2, 3, 4. Then we're looking for a baby around day 14, 15, 16. And then if baby don't implant, progesterone levels fall off, and you have a period of the cycle starts over. Okay? So you can draw that on the test if you need to, but I'll pick up what I'm going to do. I'll do girl and lecture on Wednesday. Y'all have a good day. Thank y'all for coming here. We about finished this thing. The end is inside. Let's finish strong.